So to quickly sum up why we care so much about the derivative, it can tell us all sorts of really cool stuff. It can tell us the slope of the tangent line of a function. So if I have some function here and I say, okay, I'm going to talk about the slope of the tangent line, which maybe I want to talk about the tangent line at this point right here. So perhaps my tangent line looks something like that. The derivative can actually tell me what the slope of that red line is. It can also tell us the instantaneous rate of change of a function, so it can tell us how a function is changing at one exact moment in time. And if you want an example of that, velocity is a really good example. It can actually tell us the velocity of a function if we start with a position function. So if you start with a position function, I can actually find out what the velocity was at a specific instant in time. So to think about that, that's like looking at the speedometer on your car and saying, okay, I'm going 30 miles an hour or whatever it is at this exact moment in time. Before, we were only able to look at what was your average speed from point A to point B, but now we can say, okay, exactly at this one moment, this is what my speed was. So we're going to hop into some examples of finding the derivative here. And we're going to lean on this four-step process, and hopefully this feels really familiar to what we did back in section 2.1. We're going to follow these 4 steps. We're going to start by finding f of x plus h. Really, the only difference here is we're using x rather than a constant a here. Step 2, we're going to find f of x plus h minus f of x. So essentially, we're just going to subtract f of x from what we found in step 1. Step 3, we want to find f of x plus h minus f of x divided by h. This really means, hey, we're just going to divide by h, what we found in step 2. And then in step 4, we want to take the limit of h approaches 0. Take the limit as h approaches 0. H approaches 0 of your function. So these are the same 4 steps that we did earlier back in 2.1 when we were talking about limits of difference quotients. Here we're just applying them to a general function. So our answer won't be, if we're looking for a derivative, our answer won't be a number. Our answer is going to be a function. It's going to be an equation in terms of x. So let's look at an example here. I'll start off with a linear function, probably the easiest place to start. Here we have f of x equals 3x plus 5. We want to find f prime of x. So we want to find the derivative. So I'm going to start this problem. I'm going to find f of x plus h. And this means, hey, take x plus h and plug that in for x wherever you have that variable x. 3 times x plus h minus 5. Well, we can take this 3. We can distribute that. So I have 3x plus 3h minus 5. And as soon as you get to a point where we say, okay, I can't simplify that anymore, cool, that's it. I'm done with step 1 then. Step 2, we want to subtract f of x. This is really what we want to be able to do here. So in step 2, I'm going to take what I found in step 1, which, let me change my color here, was 3x plus 3h minus 5. I'm going to take that, and I'm going to subtract my original function, which is 3x plus 5. So minus 3x minus 5. The parentheses right here are tremendously important because we need to take this minus sign right here and distribute that over the parentheses. If we don't have those parentheses, we don't know that we need to distribute that minus sign, and we will make a mistake here. So just be careful with those. We want to make sure that we include them. So we're going to take this minus sign, we're going to distribute that. Change the signs on the inside part of our function, on the inside part of our parentheses, and combine whatever like terms that I can. So I look here, let's see, I've got 3x plus negative 3x, those two cancel out. Negative 5 plus positive 5, those two cancel out. So really the only thing I'm left with is 3h. That's all I've got. So okay, again, I've gotten to a point where I can't simplify this anymore, so I'm ready to move on to my next step. My next step here, we want to take this function, we want to divide it by h here. So in this case, it's almost too simple. I'm going to take what I had last time, which is 3h, and divide it by h. So in this case, we just have 3, right? The h's just cancel. Your goal 99% of the time in these problems is to get rid of this h in the denominator. Most of the time we can do this by factoring, but there are a couple of exceptions. There are a few other tricks that we need to know, but factoring will get you through most of the time here. Step 4 then. Step 4, I want to take the limit of this result. So step 4, I'm going to take the limit as h approaches 0 of whatever I got in step 3. So here I just have 3. Well, this is just a constant, so my limit is going to be 3. This is my derivative, f prime of x. So that's how I would find the derivative of a linear function, and a linear function is almost too simple. Or we don't deal with just linear functions because, to be honest, they're not terribly interesting. We might see a quadratic more often, though. That's probably what we'll look at next. So here I have g of x equals x squared minus x plus 1. I want to start by finding g prime of x. So step 1, g prime of x, I'm going to find g of x plus h here. So I'm going to take x plus h, I'm going to plug this in for x right here and for x right here. So since I have two x values, I'm going to plug x plus h in those two spots. X plus h quantity squared minus x plus h plus 1. Remember that this guy right here, you are going to have to FOIL that out. So maybe we'll take a step and we'll remember that, oh, that's really x plus h times x plus h. This minus sign right here, we are going to have to distribute to each of those terms. So let me do that in a different color here. So we're going to take that and distribute that. So we have here minus x minus h plus 1. After we FOIL out this piece right here, this x plus h times x plus h, I'll have x squared plus 2xh plus h squared minus x minus h plus 1. Whew. There we go. So I look at that. There's nothing I can do with that. There's no like terms I can combine. There's nothing. So, okay. I move on to my next step. Step 2 then. I want to subtract g of x. So I'm just going to write out over here what I'm doing. I'm going to take g of x plus h, which I just found, and subtract g of x. So I'm going to take this whole piece right here. So I'm going to take x squared plus 2xh plus h squared minus x minus h plus 1. And I'm going to subtract my function g of x, which, remember, that's just my original function up here, x squared minus x plus 1. So minus x squared minus x plus 1. Remember, I'm going to take this minus sign, I'm going to distribute that to all three terms right there. So I'm just going to change that minus sign to a plus sign and then change the signs inside of my parentheses. So I should have plus negative x squared plus x minus 1. And look at right here. So we have x squared plus negative x squared. Well, those two are going to cancel. Negative x plus positive x, those two are going to cancel. Positive 1 plus negative 1, those two are going to cancel. So all that I'm left with here is 2xh plus h squared minus 1. Oops, minus h, excuse me. That's all I've got left over. Again, I can't simplify that. There's nothing much I can really do there. Which means I can move on to my next step. Step 3, I want to divide by h. So I'm going to take g of x plus h minus g of x, take that whole thing and divide it by h. So I'm taking what I just found in my last part, 2xh plus h squared minus h, take that whole thing and divide it by h. And remember, your goal here, we want to get rid of that h in the denominator. That's what we want to end up doing here. So So I'm going to factor an h out from my numerator, just like I did last time. I have 2x plus h minus 1, all of this divided by h. Then we can cancel that h from the numerator and the denominator, and I'm left with just 2x plus h minus 1. So that's awesome. We're ready to move on to our last step then. Our last step then is, hey, let's take the limit as h approaches 0 of whatever I ended up with at the end of step 3. So here I have 2x plus h minus 1. So this is just a really nice polynomial. I can just plug 0 in for h. So this says 2x plus 0 minus 1, or just 2x minus 1. So here is my derivative g prime of x. So this is probably more in line with the types of answers you'll be getting when you find derivatives. Here we have actually a function that's in terms of x. We have 2x minus 1. Next, so I want to keep working with this derivative. I want to kind of get comfortable, get used to using it to identify things. So here in part B, I just want to find g prime of negative 2. Well, here g prime, we said g prime of x over here was 2x minus 1. This really says, hey, I'm going to take negative 2. I'm just going to plug that into my derivative. So g prime of negative 2, that's equal to 2 times negative 2 minus 1. This is negative 4 minus 1 gives me negative 5. So here I've evaluated my derivative, at negative 2. I ended up with negative 5. That's all I need to do here. Part C, we want to find the equation of the tangent line at x equals 0. And here is a problem that we'll be seeing a lot of here. So if you think about what we need, if we want to write the equation, I don't want to worry about tangent line quite yet. Just think about the equation of a line. If I want to write the equation of a line, you always need two things. You need a point, so I need a point x comma y, and a slope. You could do it with 2 points, but you end up needing the slope anyway. So I need a point and I need a slope. So what do I have? I have an x value. I know my x value is 0, which means I need a y value, and I need a slope. So we have to go find these things. Let's start with the y value. I think that's going to be easier. For the y value, if I want to find the y value, I'm going to take this x value, this x equals 0, and I'm going to plug that into, I gotta scroll back up here, my original function, g of x. That's what tells me the y value. So I'm going to take x equals 0 and plug that into x squared minus x plus 1. So here, g of 0 is 0 squared minus 0 plus 1. So this is 0 minus 0 plus 1. This is simply just 1, which means that is my y value. Oops. So g of x, this is what tells me my y value here. So now we're going to come back, we're going to talk about the tangent line. Now is when I want the slope, but I don't just want any slope, I want the slope of the tangent line right here. So what tells us the slope of the tangent line? If I'm thinking about slope of the tangent line, how can I find that? Slope of the tangent line. Well, that is, we can find that, we said earlier, by using our derivative, g prime of x. So what I'm going to do is I'm going to take this same x value over here that I used last time, 0, and I'm going to plug it this time into my derivative, g prime of x. So g prime of 0 equals, and I'm going to look at my derivative, which is right here, 2x minus 1. I'm going to plug 0 into that equation. So here I have 2 times 0 minus 1 gives me 0 minus 1, or negative 1. So that means that g prime, let me summarize it right here, g prime of 0 is equal to negative 1. That is the slope of my tangent line. So m is negative 1. So this is pretty cool now. I have everything I need. At this point, I have my slope. I have my point. I'm ready to go. I'm ready to write the equation of this line. And there's a few different ways you can do this. You can use good old y equals mx plus b. I prefer to use a point slope form, so I prefer to use y minus y1 equals m times the quantity x minus x1, where m is the slope, that part doesn't change, and x1 comma y1, so here, let me write this right here, x1 comma y1, those are just the coordinates of a point that are on my graph. So I'm going to take my points and my x-coordinate and plug that in for x1, my y-coordinate, plug that in for y1. So y minus my y-coordinate, what was that? Well, my y-coordinate was 1. So y minus 1 equals m. What's m? M is negative 1. Negative 1 times x minus my x-coordinate. x1 was just 0 here, so x minus 0. You could leave that as it is. I think that's kind of what my math lab does, but most of the time I'll just say, just go solve for y. It's not too bad to do. So here y minus 1 equals x minus 0 is just x, and then times that negative 1, I've got negative x. Add 1 to both sides, y equals negative x plus 1. This is the equation of the tangent line at x equals 0. So if I was to graph my function along with this line that I've just found the equation of, I would see that that is actually the tangent line at x equals 0. So this is a problem I would definitely practice and I would definitely review on, because you're going to see this problem, find the equation of the tangent line, a lot here. We're going to be doing that a lot in this class because we want to really understand what does the function tell you, what does the original g of x tell you, and then what does the derivative, what does g prime of x tell you. And this is a really good way to kind of practice distinguishing between those two things.